Hi, welcome to this Open Security Summit session in November 2021, where I'm going to be talking about a really exciting framework that we've been developing at Glasswall for basically testing a lot of our APIs. And this is all about creating a scalable, basically test framework. And we use Elastic and AWS, and I'll walk you through the details of this. So fundamentally, this is a story about scale. So what you see here is one of our Kibana dashboards, where you can basically see that we generated millions of files, terabytes of data, and we had a very low error rate, and I expand on that in a second. And in our case, what we do is we process files, so Glasswall makes files safe. So this is basically our kind of also a bit of business intelligence, where for a lot of the files we process, we detect if there's kind of high, medium, low risk, which depends if there's metadata, macros, JavaScript, etc. on it. So it's interesting to see in one place you get both the scale, but also the business data mapped to it. The main thing I'm going to cover here is talking about achieving scale, the problem we're trying to solve, the first attempts we've done, the kind of the tech stack, the CLI command line interface that we built, the AWS event bridge and lambdas that we use fundamentally, and then a bit about Elastic, and finally just some lessons learned. And feel free to ask questions along the way, come off mute or just ask on the chat, and we keep an eye on it, and then we'll try to answer them. So the first challenge here is, scale is difficult, right? Anybody who try to do it, will tell you that things break when you achieve scale, right? Everything becomes a problem, from bandwidth to service to even the cloud providers. It's all nice and good when you're running a couple of things. As soon as you're trying to achieve a whole bunch of volume, everything kind of slows down. So what was really interesting about our world here is that you could see that, we basically are processing millions of files and, a very small error rate. And in a way, you could see that the number of the sheer volume of requests, right? So at the point here, we were sending, basically about 300,000 files per hour. We were basically sending, 150 gigabytes per hour, which is quite a significant amount. And we actually could have gone much higher, for example, some of these tests, and we've seen it higher. It's just on this particular case, we were almost like, there's a point where you go, how much more you want to spend, right? But it's really powerful to be able to show and to see, the platform, and more important in this case, the test framework to scale. So the first two key concepts that I really want to talk about is we've created two types of tests, and these tests are very important in a particular way. So you can actually see here on the right, where you'll notice that, here where my mouse is, you'll notice that there is, the green line represents number of files, and the blue line represents file size. So what you kind of see is in the first execution here, on this execution on this period here, what you see is that you have a lot of files being sent, but not a lot of file size. So this is what I was basically calling a pure quantity test. We're just trying to figure out what is the raw capacity of the platform without looking at any kind of hard work for the platform. So in this case, in this particular case, what we were doing is we were sending a very, very small file. It's a 700-byte file for the engine, which the engine can process in 100 milliseconds, right? So, and 120 milliseconds. So we were not really testing the engine. What we were testing is everything else. And the reason why this is so important is because when you're doing this type of tests, and when you're doing this type of volumetric tests, it's super important that you remove variables from your environment. It's super important that you basically try to control as many variables that you have, and have as many little of them playing around at any moment in time. So in this particular case, I really wanted to make sure that we understood the raw performance, not just of the engine, but also of the test framework. So you could see that we were basically sending more and more and more requests, to the point where we were sending 350,000 requests per hour, right? Which is a pretty decent amount, right? And And that was, also super critical to understand, how everything fits together. Now, that test is testing the fundamentals of the framework. The second test that we then done was, now let's make the engine work. Let's go to the target, in this case, the engine to process files, and actually make you work hard. And that's what the second test is. So that's why you can see that in the second test, we now sending a lots of different files, and we're sending lots of different file sizes. That's why with the second test, we were basically now hitting, the 186 gigabytes, a bit more per hour, which is why then all things combined, we hit 1.9 terabytes of data. So it's super critical that you really understand this. And the other element of this is that we also were testing AWS Autoscale on this, which worked really, really well. So the logic here is that we want a system that, as we increase the traffic on the side and as we increase the load, the auto-scaling goes with it. And this test framework really allows us to do that, which was super powerful. So highly recommend you have one type of test that is purely about, sending something reasonably simple to the platform and making sure that everything is still going as it's supposed to. And then the second one is about super volumetric tests, right? And now, here's where you can see it in action, because what you can see here is this is a 2-hour slots from the big run. And what you can see in this period, where we basically send 500,000 files, and so this is 2 hours, and 323 gigabytes of data, right? And you can actually see the error rate in here, because we actually are just going for files that we kind of almost want to measure. In this particular case, we only send files that we knew the engine could process, because we were after the raw errors of the platform. So you can see that the number here is insanely low, right? This is actually out of 512,000 files, we had 42 errors, which we kind of start to believe that we're still debugging some of these, but some of them are literally HTTP errors and network problems within AWS in itself, right? Because the platform was actually performing quite nicely. Some of these delays had to do with the way the data is sent. But what's really interesting is that here below, what you can see is that this line here is the canary run that is basically tracking, even although there's a lot of load above. And remember that this is like hovering about 1 second. It's hovering about 2-3 seconds on average. This is where, even although the platform is in quite a lot of load, and we're sending quite a lot of traffic to the platform to the tune of 150 gigabytes an hour, right? The canary run, which is the run that is the simple run that basically represents a new user coming to the site or to the application doing something simple, it's still doing it well. And that's very important, because what you want to make sure that you have almost a correlation. You can see here, if there's a bit of a spike of traffic, it makes sense to have a bit of spike there, right? And they should be reasonably correlated with each other. But what's very important is that this line here stays reasonably constant throughout your big load, because it means that although the platform has an insane amount of loads, it's still handling okay every new request for every new user. And that's super important. So the problem we're trying to solve is, especially with the test framework, is how to generate lots of traffic. Generating lots of traffic is actually very complex. It's not trivial, it's not easy, because the same way that you want your application to scale at the other end, you want a test platform to also scale, right? And it's not easy. And the thing I would say is that when we look around, and I'll cover that in a second, it's very important to have a level of interactivity with your engine, right? A level of customizability, because some of these things you only discover them as you go along. So you can see that, and if you know, I'm a big fan of Worldly Maps, and my approach on this is that you want to basically be commoditizing and productizing as much as you can, and always creating mini tools and mini sort of environments that allow you to have almost this sort of multi-lever kind of environment that allows you to control exactly what you're trying to do. So fundamentally, the challenge here is how to generate lots of traffic to in context for a particular application that does specific things. So you can't just send traffic blindly. You have to understand the application, customize it, and then be able to very quickly iterate the type of tests that you actually are doing. So the first attempts that we do, actually, I'm going to pause for a second. I just need to open the door. Oops, let me just pause the recording for a second. So the first attempt, right? And when we try to look at this, we always try to leverage whatever we can that already exists, right? There's no point in reinventing the wheel when something already exists. But the thing that we found with some of the online services and some of the tools that existed, and namely, for example, we use JMeter. In fact, the first couple of versions of this were built on top of JMeter and other things, is that the customizability, right? And the ability to write almost infrastructure as code and have very quick deployment environments and have a level of control of what actually going on very quickly became a problem. So what we end up with is actually a platform that we can now leverage other tools, but it's very well customized to the way we want to work on, right? So this is my approach on this is always like this, right? You leverage as much as you can, but if you have to write your own stuff, never hesitate, because if you don't, we actually spend quite a bit of time initially trying to make these other technologies to work, and then you're fighting a system, right? You're building systems that are not hard to use, hard to customize. And although they might start well in the beginning, you very quickly hit some points where they almost become an overhead in itself. So you hit that typical Worldly Maps attrition point. So sometimes it's better to say, well, okay, let's learn from it, but then implement whatever we can our way, but also leveraging. If you look at the platform fundamentally is leveraging a lot of serverless components. So it's building on top of a lot of other automation that gives us a lot of flexibility. So the tech stack for this is fundamentally a kind of a CLI, a command line interface that allows a lot of customizability, but also a lot of control of what's going on. You think about knobs on and off. There's a rules database that controls the rules that are being executed. There's an event that triggers every minute. And then for every basically event that is triggered, you basically have, and for every run that is on the rules database, everyone that's enabled, you start, a session for every target, for every, count, because there's a rule that depends how many times you want to run, and then you run the rule. And then you publish everything. So in practice, what it means is we use Typer, which is a great Python API for creating fast CLIs. We have Elastic Index for the rule database. We use the AWS Events Bridge. Then we have 3 Lambda functions, all invoked async, and then you have Elastic. The coolest thing of this is that every one of those is actually not, it's easy to replace in its own bits, right? And there could be different variations that, we can have on this. And so I don't feel that, for example, this solution is very tied to AWS. Actually, we want to develop a Kubernetes native version of this. What we're almost leveraging is, for this part, for example, Lambdas are great from a scalability point of view. Event Bridge solves the invocation element. Elastic, especially on the visualization, like I should put Kibana here, right? Makes a massive difference, right? In how everything plays together. So the flow here, and I want to kind of mention CLI because I think it's super critical. What's really important when you look at this CLI and this kind of environment, right, is that this CLI was developed organically, right? And of course, that eventually you trim it down, right? You kind of normalize it a bit based on usage. But we actually created for this like 5 or 6 different CLIs. One focus on a particular thing, but you kind of can see that if you look at the names there, you got copy, create, delete, disable all, enable, execute, info, list, right? The Gov UK, for example, is that we have a great data set from the Gov UK that we downloaded, so you can just add that to a queue, rename, run types, etc., and setting up the data, right? So this is really critical because one of the most important things of this framework is that I can turn it on and off, right, on demand, right? And that's super critical because I would say when you have a test framework, it's super important that you control it to a very high degree. And that was another thing that sometimes I would struggle with some of the other environments, that I really want something that I can turn on and off, because we were also using this to understand the behavior of our platforms. In fact, in the first versions of this, we were actually finding lots of gaps in some of our APIs because they struggle under load. So it was very important to be able to go to the point where everything was fine, leave it there for a little bit, then go up a bit, then see this thing start to wobble, then bring it down, see if it recovers. And if it does recover, that's cool. If it doesn't, you just found something that needs to be fixed, because you do sometimes have those scenarios where the platform is great, but the moment it struggles, for some reason, it doesn't recover to where it's supposed to be. So again, that sort of dynamic on and off is super important that you have. And then you want to make sure that once you find that spots where it starts to wobble a bit, you can also go higher, right? You can go higher and higher to basically see almost like how much traffic do you need to send to an environment for it to break. And I think it's important that you understand that. I think it's important that from a security point of view, but also from an engineering point of view, how much traffic do you need to send to your platform for it to really start to wobble? Because there's things you can do with it. There's decisions that you can make, and you also need to have an environment that can create that load so that you can make, in a way, those decisions. So I highly recommend that you look at something like Typer. It's a great way to create Python scripts, Python CLIs, which really allow a level of interactivity, right? It allows to codify a lot of the things. This is where you basically, for example, edit the rules. So if you look here on the right, what you see here is the rules. In this case, they're all disabled, but you can name them. This is a particular test that we're doing. You have a set of run types, which are actually little bits of Python that now are being normalized and refactored so that they actually, basically are very easy to write. So you can almost think of them as a serverless little module that now can do something much more specific. You've got the delay, we actually got to the point where we can send lots of files very quickly. So then that can become a problem in your platform. So maybe some platforms struggle if you send 50, 100 requests in parallel or 1,000 requests in parallel. So you probably want to go, okay, maybe send a request per every second, right? So instead of having, one, burst of 60 requests or 100 requests or 500 requests in the first second or 5 seconds of a minute, you have kind of more distributed. And then there's the target that you can set. So you can see what goes from load balancers to other types of things. And then this data here is actually something we added very recently, where we then looked at creating name value pairs that we can then pass to the run type. So for example, we actually use that feature to implement a mode where you can now say, here's the bucket, here's the key, sorry, here's the S3 folder or the filter that I want to use. And then basically you query S3 and they basically process all the files inside that S3 bucket. That is really cool because it means that you can now have a bucket that has all your test files or a particular whatever you want to load in your test, that then your test run can actually execute it. So that is insanely powerful. So I cannot underestimate how powerful it is to have a CLI when you're doing this type of test, even development, but especially for this type of tests, it helps a lot. It also helps a lot with the teams using it. And what you're doing is you're creating now the materials for your next batch of users, right? Who are then going to use this, right? And then, use in their internal tests or eventually, shared with customers. So the AWS environment that I kind of want to describe is fundamentally, three elements of this, right? There is, basically an event bridge. If you don't know what it is, basically it's a AWS service that fires up an event. So actually, I'll go through here because I can actually explain it better. So you have an event bridge that basically fires up every minute, right? So every minute there is a new event that triggers this Lambda function. So that Lambda function, the job of that Lambda function is to read the rules database. So if you think about that, you control what's going on by the rules database, which is independent from this, because this runs kind of in its own sort of continuously. So if there's no rules on the database, you basically have one event, one Lambda function per minute, and that's it, right? Which costs 0.001 cents, right? Whatever. So that's almost a framework at pause. There's no event, there's no rules, it doesn't do anything, right? If there is a rule enabled, then what happens is this Lambda function calls this other Lambda function, which is going to basically look for targets. He actually, at the moment, the framework, and this is why it's important for us to customize it, supports two types of sort of rules. So two types of targets. There's a target where you give it one specific target, let's say a load balancer, and then that's it, right? So with the load balancer, you're just going to hit that and everything is behind it. We have another mode where we can actually start 20, 30, 40, 50, 100 servers in, for example, 10 different regions. So there's a command, which is pretty cool. I can go, hey, deploy a version of our cloud API, give me 10 of those in 9 different regions. And that literally is going to spin up, 90 independent versions of our main product, right? and then you can send traffic to each one of those individually, right? And what's really interesting is that we've done tests where we would do something like this, and we would send the same amount of traffic, the same amount of files with the same basically Kubernetes cluster, because this was literally 90 Kubernetes clusters. Actually, I forgot to mention that when you had there, 5 million or 6 million files, that's 6 million Kubernetes pods that were executed, which is pretty cool, right? So we found that when you send the same amount of traffic to all these different servers, there's periods where they work all perfectly, and there's periods where they don't work perfectly. But it's not consistent. It's not like maybe the test framework is wobbling. It's not like something is weird going on from sending the traffic. It's just the servers kind of have less resources. And it makes a bit of sense, because if you think that you're in a shared infrastructure in AWS, what you could have is you could have network issues in AWS. You can have servers that have less resources for a little while, or some SLAs or something else you hit, but it's not consistent across the board, which basically indicates that, necessarily is not our application that starts to wobble exactly after 3 hours, right? Because we've seen in some cases where that happens, right? So a memory leak eventually will hit every server at the same time if they're having the same type of traffic. So what was really cool about this is that we actually start to see that we also, especially in a cloud environment, you need to start to add capabilities to your application to start to defend itself when the application gets less resources from the hardware that it's supposed to be in. So it's interesting that we now start to change the capability or almost like the availability of a particular server or a particular node in Kubernetes, right? But in this case, a particular EC2 instance, we almost say, hey, this one has less capacity. Don't send so many files to it. But we only can see that because we can say for sure that it's not in our code this is happening, because there's a server next door and next door. There's exactly the same thing in the same region that doesn't have that behavior. So that's kind of the targets that we catch. And then going back to this, so Ben, if EventBridge runs a request every minute, so how it works, EventBridge triggers every minute, calls a Lambda function 1, who checks the rules, calls a Lambda function 2, who checks the targets. This is an extra check because we have a way to say, by the way, run this rule, n times, and then you start the final Lambda function, which is the one that is actually going to run the test run. So this last function, which is basically is one per rule, per server, per target, that gets invoked, per count, and basically that is the one that again is independent. So if you think about Lambda functions are fundamentally Docker containers that are running, or processes that isolated that are running, that is the one that is actually going to make the requests to the servers. So you get a greater level of isolation, but you're also leveraging AWS scalability, right? So this thing will scale. We run 300, 400, 500, 1,000 Lambda functions, right? No problem at all. It's all nice and good, right? And then all of this is actually sending data to Elastic, and that is again super powerful. And I'll cover that in a second when I talk about Elastic. But these workflows scaled really, really nicely. We had very little issues with this, and this allows us to generate the kind of traffic that you basically seeing here, right? That's the traffic that you see here was all generated from those Lambda functions, which is actually pretty cool. So that's the Lambda functions. The thing about Elastic, there's 2 parts of Elastic that I want to cover, right? Is the first part is the Elastic itself, the Elastic, basically almost Elasticsearch part of it, and then the Kibana part of it, right? So the Elasticsearch, what is interesting is that Elastic has been designed to handle millions and billions, right, of records, right? So if you are dealing in millions of records or hundreds of thousands or even less, Elastic is insanely fast, right? And it scales really nicely. And fundamentally what Elastic does is they index everything. So I view like Elastic is like a relational database where every field is it's basically indexed. So you can query, you can filter, you can do all sorts of things to it, right? And it makes a massive difference, right, in how you handle this. And for me, the key here is to massage the data before you send to Elastic. So what I think one of the biggest mistakes that I think a lot of teams do when they do data science and big data, and I've seen a lot of security teams do this, is that they tend to send the raw data to Elastic or to the index that you have, and then you filter over there, right? What I found is that that is always very expensive. And usually these platforms, and there's Elastic, there's Splunk, there's a bunch of others, right? They're not very good at it, right? Because by then, you have to do transformation on top of transformations, right? Or on top of the data. What works insanely well is to clean up the data before it goes to Elastic. So, and also the good news of that is it's kind of a one-off hit, but it's fine because you're paying that hit, for example, in the process of a Lambda function being executed. So it basically means that, all right, the Lambda function takes, instead of taking 2 seconds or 5 seconds, takes another 10%, right? Or 30% or 15% of the time. But it means that the data, as it arrives in Elastic, is now really well tuned for visualizing the data in Elastic. And that's the other thing. I don't like this idea that you use Elastic as a native data store. You should have, your data should already leave for the logs and stuff like that. You should be able to have to persist it, then send it to Elastic, right? So in this particular case, what we're doing is that, we when we capture the data, we actually send a really nice, it's basically a JSON file, right? It's a really nice JSON file that actually contains all the information about the test or that particular run. And it kind of means that maybe there's a bit of redundant data in there that you can do with a relational database. But the advantage of doing that is that it's very easy to query. So for example, like you send in the same, every one of those test runs, you send the server that you went, the version that you go, some extra metadata where environment is running. And what that gives you is then the ability to very quickly cross-reference, and create all sorts of visualizations. More importantly, the next part allows to create some insane dashboards, right? So the second part of Elastic, after the first one that scaled really nicely, is the latest version of Kibana, is especially with the lens functionality, which I'll cover some more in the session tomorrow, is really easy to make dashboards. And that is very, very important, because creating dashboards, again, is an interactive process. So when we build the test framework, it's very important to be able to create something, modify it, have some data being sent, then go back to Elastic or to Kibana, trying to do a dashboard, realize, I need this data. I need this data point. I really wish I could filter this like this. So then you can go back to your test framework, make a code change, and then affect your UI. And I would say, in a nutshell, that's almost what you want from the test framework. You want an environment that not only you can, of course, do a lot of the runs and there's things that become quite mature, but you want an environment where you can iterate very quickly from seeing a dashboard and saying, I need something here, right? I need, I need a new UI. I need a new, like something like this, right? Oh, I need to capture a number of unique files. I need to capture the percentage of errors. I need to capture the duration. And there's a bunch of other stuff that we capture. You need to be able to then go to your test framework and understand, well, which duration I actually care about. So you then need to go to exact place that has the duration that you want. And you need to make sure that that is then available to basically that JSON file that you're sending to Elastic. And I feel this is where a lot of the visualizations, a lot of efforts break, because if you don't create something like this, then it becomes really hard to make changes. It becomes really hard for the team, for example, trying to create dashboards to influence the quality of the data that they have. And then they become very inefficient at trying to go to doing all sorts of stuff. And I've seen lots of things even on Jupyter notebooks and things like that, which is great. But sometimes you want to do that as the data goes to your pipeline. So if I basically say that what's one of the most important properties of this test framework is, I would say that it's the ability to iterate very quickly between the rule that you're writing and the dashboard that you're creating, right? That dance, that feedback loop is almost how this was developed, right? So this was a good example of a project that was developed, in parallel. A bunch of other stuff was going on, but the way it became to life was because we were very efficient in a way that we were coding and creating this because of the feedback loops. And ultimately, the feedback loop is that interactivity between I'm looking at a dashboard, I'm asking a business question, I'm asking a technical question, I want to see this, I want to see that, what about this, what about that? And then you need to be able to go to the code, to the rule, and you need to be able to have an environment, which is why we created the rules architecture, where you can make a couple of changes, publish that Lambda function, publish that to an environment, even test it locally, run again, and then very quickly see the feedback in your dashboard. So one of the tests I'm asked every single developer that we have is that if we have developers that are not seeing in real time the impact of the code that they just wrote, and when they push a change, they need to see this, because what that allows them a level of speed and interactivity that is super powerful. So the logic here is that this testing from a framework tool is not just something to be used by the developers or the testers, sorry. It's something to be used by not just the QA, but also the SRE team and the sales operation team and the customers and the developers, basically, and the execs and the project managers. Everybody should be able to have the ability to turn on and off the traffic, understand, see comparisons between the different versions, ask for little tweaks to be done, because they want to see data in a particular way. And if you cannot do those changes quickly, there's something kind of broken in your kind of development pipeline, which is ultimately why we built the framework in the first place, is because for me, that interactivity was kind of key on this. And now, finally, right, I think lessons learned from this is that, having, in a way, a test framework, right? It's almost like the sooner you can add one to your project, the better it is, right? So I feel that there's two types of lessons. There's types of lessons of how the test framework was developed and how effective his workflow was, because I was basically, and the team was using the test framework to build a test framework, which also always helps, right? So you get that level of interactivity. And then the second part is that the sooner you can start to send all sorts of traffic that you can customize, especially one that you can turn up and down the volume into the traffic, the sooner you pick up a whole bunch of stuff, which of course is always better that you find out sooner rather than later, because it's cheaper to fix, and it's always better than not to discover that at 2 o'clock in the morning when a massive spike of traffic, or a customer starts to send a lot of traffic to your site that you're not expecting. So the sooner you can get a test framework built in, and the more you see the test framework not as some kind of nice add-on that is just doing some volumetric testing at the end, but as a fundamental piece of the test infrastructure, kind of the better it is. And kind of that's part of this presentation. Any questions? I know I was kind of accelerating a bit, but any questions on this? No, if not, I will end the session. The video will be online, will be on YouTube very quickly. And then I'll see you on the other sessions.
Thanks, Dennis.
Hey, cool. No worries.